Hello, this is Professor White. Today we will go over scientific notation. It's an application of exponents, and it's a great application, and some calculators are set in scientific notation, and sometimes the students do not know how to deal with it. You can change the setup of your calculator by going to the mode most of the time, or if you don't know where that button is, and you can maybe get a manual from online and try to figure it out. So let's go over scientific notation. Scientific notation is a notation that has an exponent in it. It is a number times 10 to an exponent. And that exponent can be negative or positive. But what's important is this number in front of that 10 to the exponent has to be between 1 and 99.999. It cannot be 10. It cannot be bigger than 10. It cannot be smaller than 1. So let's look at this. How do I go from a regular standard notation to scientific notation? So this is 312. I know 312 is when I try to write it as a number. So there is an invisible decimal here. I can move my invisible decimal here, and that makes it a number that's less than 10, bigger than 1. Now, my decimal used to be here. I moved it to the left. How many steps? 1, 2. Okay? So if I put 2 in here, this number is going to be the same as that, because 3.12, 10 to the 2 means 3.12 times 100, and that will give me 312. So I did this right. Okay, so 312 in scientific notation is 3.12 10 to the 2. So when you have a big number, this number is going to be positive. When you have a small number, this number is going to be negative, and I'll show you how that works. 0.312, if I write this number with a decimal between 1 and 99, I need to move that decimal here, 3.12. Do you see it? And since this number is small, it's going to be, and I moved it 1 decimal, so it's going to be negative 1. So what that means is 3.12 times 10 to the negative 1, which means 1 over 10. So I'm taking 3.12 and divide by 10, which is 0.312, and that happens to be this number. Okay, big number. That means I need to move the decimal someplace. There's an invisible decimal here. It's going to move here, so that's going to be 4.6. And since this is a big number, I move 1, 2, 3 steps. It's going to be positive 3. So let's check. 4.6 times 10 to the third means 3 zeros. 1, 2, 3. That means I'm supposed to multiply 4.6 by 1,000. So that means 1, 2, 3. Okay. This is not right. So I need to account for these 9, 3 as well. So let's put that. I forgot that. That will give me 4,693. Very good. How about this one? This needs to be 2.45. And it moves here, 1, 2. So 2 steps. And since it's a small number, it's negative. Let's check. 2.45. 10 to minus 2 means 1 over 100. And when I divide 2.45 by 100, I get 0.0245. So these are all scientific notations, and these are the checks. Okay? Do you see all of them? All right. If you look at them, these parts, they all are between 1 and 9.99. And these ones are exponents 10 to the, it's always 10 to the something. All right, for scientific notation. Now, what happens when I want to do very small numbers and do this? Sometimes it will be too difficult. So maybe what you can do, you can actually write these in scientific notation and see if it helps you. Okay? You can go 2, 10 to the. So this one is 1, 2, 3, so that's negative 3, plus. This one is 4, 10 to the. 1, 2, 3, that's negative 3. Guess what? I can actually factor out this, and 2 plus 4, that gives me 6, 10 to the negative 3. Did that make it a little bit easier? I think so. Let's try this one with scientific notation. What is this one? It's 2, 10 to the, so let's count 1, 2, 3, 4, since this small number is negative, times 4, 10 to the, let's count 1, 2, 3, 4, 5, so that's negative because it's a small number. Guess what? I can multiply these two, that's 8, and I can multiply 10 to this. Remember how you do the exponent multiplication? You add the exponents, negative 4, negative 5, so that's negative 9. Okay. How about these guys? Believe you me, this is going to make your lives a lot easier. So I'm going to write these guys with scientific notation. 4, 10 to the, let's count. 1, 2, 3, 4, 5, 6, 7. How about 2, 10 to the, 1, 2, 3, 4. Now, 4 divided by 2 is 2. 10 to the top, bottom. Remember your exponents. Subtract the bottom from the top. 2. 10 to the 7 minus 4, 3. This is a lot easier than dealing with all these zeros. How about small numbers? Okay, how about this one? It's 4, 10 to the small number, so it's a negative. Let's count. 1, 2, 3, 4, 5. Divided by 2. 10 to the small number, so it's negative. From here to here, let's count. 1, 2, 3, 4, 5, 6, 7, 8. Now, let's divide. 4 divided by 2 is 2. Let's do the exponents. 10 to the, I have a negative 5. When I move this up, it becomes positive 8. 2, negative 5, positive 8, that's positive 3. Here we go. Guess what? This is way easier, the exponent notation, scientific notation is way easier than dealing with all these zeros. How about a big and a small number? Not a problem. I'll write the big number as 2.4, 10 to the. Okay, let's count. 1, 2, 3, 4. Big number, positive, times 2, 10 to the small number, so it's going to be negative 1, 2, 3. Now let's multiply these two. 2.4 times 2, that's 4.8. Remember how I do the exponents? 10 to the 4 minus 3, that's 1. This actually turned out to be 48 if you go back. And this is way easier than dealing with that. All right, so make sure you understand your exponents before you do the scientific notation application. But once you review your exponents, you can do all these big number, small number business using the scientific notation. Your calculator can also help you. There's a scientific notation mode in there. Try to find that. You can double check with your calculator, but you can do with all these operations by hand. without really using a calculator when you use the scientific notation.